All right, thank you for attending, and I would like to welcome everyone, and I would like to talk a little bit about our speaker before I invite him to the stage. So bear with me for 1 second. I want to get his PowerPoint up before I get too far with this. Okay, Dr. Joseph Romm is our speaker tonight. This is our fourth distinguished speaker in our Distinguished Physics Seminar Series. In the past, we've had Professor Jim Gates from the University of Maryland. We've had Dr. Neil Lane, who was former head of he was former provost at Rice University, and he was also known as former head of the National Science Foundation. And then last year we had Dr. John Hawley, who was the chair of the astronomy department at University of Virginia. This year we add Dr. Joseph Romm. Dr. Romm is a senior fellow at the Center for American Progress Action Fund. In December 2008, Dr. Romm was elected a fellow in the American Association for the Advancement of Science. He also served as acting assistant secretary and principal deputy assistant at the U.S. Department of Energy's Office of Energy Efficiency and Renewable Energy. He has a book out called Hell and High Water, Global Warming, the Solution and the Politics. Dr. Romm holds a PhD in physics from MIT and did his research thesis on physical oceanography at the Scripps Institute of Oceanography. I'd like to welcome to the stage a fellow MIT physics alumni, Dr. Joseph Romm.
I realize this is not the most upbeat of subjects, so I greatly appreciate people interested. I'm going to talk about climate science, and I'll talk about climate solutions. I spent much of my career in the clean energy arena, working at the Department of Energy and working with major corporations on clean energy. And when my brother, who lived in Pass Christian, Mississippi, lost his home in Hurricane Katrina, he lived about a mile inland, and they had about 20 feet of water. He was trying to figure out whether he should rebuild his home in coastal Mississippi or not. Obviously a tough decision for anybody. And so I spent a lot of time talking to the leading experts on climate science and hurricanes, and sort of came to the realization that the popular understanding of climate was not, or what the scientists believed about climate was not what the general public understood. So I wrote a book and started a blog, climateprogress.org, and just spend my time communicating on climate and clean energy issues and politics, climate politics and the like. I have a strong affinity for Houston, been here many times. I actually worked for Bill White when I came to the Department of Energy. Bill White was deputy secretary, and I was his special assistant for 2 years, so I got to know him, and obviously you've gotten to know him as mayor, and he's certainly a remarkable person, and I certainly am happy to be able to say that I hope he becomes the governor of your fine state. He's not your typical politician, but he is one of the most thoughtful people around. And so let me talk about climate science. It's been in the news a great deal. I think it is going to affect I think climate change is going to affect the lives of everybody here, and those of you who are younger, those of you who are students, is going to have a big impact on your lives and the kinds of careers that will be created by climate change are, I think, ones that people need to understand, because I do think that global warming is going to remake the landscape of the country and remake the economy. I just want to start with a statement by the Royal Society of the United of Great Britain and their meteorological office, which is part of their Defense Department. This was in November. They are talking about every 5 or 6 years, the scientific community comes together and does an assessment of the climate science literature, and that's these IPCC assessments. And it's clear, the latest assessment was in 2007, and it stated clearly that without substantial global reductions of greenhouse gas emissions, we can likely expect a world of increasing droughts, floods, and species loss, rising seas, and displaced human population. And even in just the last 3 years, the evidence for dangerous and long-term and potentially irreversible climate change has strengthened. I think it's pretty clear that of all the places in the country that are going to be hit by climate change, the Gulf Coast and Texas are near the top of the list. Climate science is pretty straightforward. I think it's been made to sound less solid than it really is. But, many decades ago, scientists predicted that if you keep burning fossil fuels and putting carbon dioxide into the atmosphere, you would keep trapping more heat, and the planet would start to warm up, and you would see a variety of changes in the climate as the planet warmed up, which I'll discuss in a bit of detail. But the hotter you get, you create more evaporation, more water vapor. That means that storms tend to be more intense. It also means that because of the evaporation, dry areas tend to get drier. You also see you're starting to see impacts that scientists didn't really expect. As you change the climate, you get more invasive species, and in the west of the western United States, we've seen these tiny bark beetles, which used to get wiped out in the cold winters, now survive the cold winters and have just exploded. And really, if you've driven out west in I-70 in Colorado or been to Helena, Montana, or other large parts of the West, you see these bark beetles are just devastating the trees, and the trees, because it's hotter and drier, they don't have as much sap to release to kill the bark beetles, and as a result, more trees die and you get more wildfires. And so much of what scientists predicted came true, and now scientists tell us that if we keep doing what we're doing, just burning fossil fuels, and that's coal, oil, natural gas, using cars the way we use cars, electricity the way we use electricity, the planet would warm 9 degrees Fahrenheit this century with many serious impacts. And like I said, the science is quite straightforward. You burn hydrocarbons, you release carbon dioxide into the atmosphere, the CO2 traps heat, the planet warms up. And even back in 1979, the National Research Council said that if you just double carbon dioxide concentrations, you're going to end up with a warming of 3 degrees centigrade, which is over 5 degrees Fahrenheit, and we're going to exceed that level of CO2 by a great deal. This is the global land-ocean temperature index in degrees centigrade over the past since 1880. We've warmed roughly from here up to here, and it's about 0.8 degrees centigrade, 1.5 degrees Fahrenheit. Not a lot of warming yet. We've been warming very, very slowly. There are a great many lags in the warming system, but as you can see, lately, we've been warming pretty rapidly, and the last decade, the decade of the 2000s, was the hottest decade on record. And as I say, it's you hear a lot of I think bad reporting in the media that somehow we're entering a period of cooling. It's just silly. We've been, like I said, this is the hottest decade probably in many thousands of years, as one top climate scientist put it. And of course, when you warm up the planet, you get melting. That's sort of the most obvious impact, is that everything starts to melt. We've actually melted 2 trillion tons of land ice since 2003. Let me make another point. I'll show you some pictures of the melting. Most of the heating, though, doesn't actually go into the land. It actually goes into the ocean. The ocean has a great thermal capacity, and so the oceans have been heating up. This is down even to, this is a little blurry. This is down to 2,000 meters, down to 1.2 miles. This is the heat content of the ocean just since 2003, just the last several years. The ocean heat storage has been going up and up and up. And that's going to have serious consequences for Houston, as I'll come to shortly. Obviously, the first thing that happens when you heat up the planet, the most visible thing, is you just start melting ice. And so you perhaps have seen the pictures of the melting ice. This is one glacier on Mount Everest. This is the Matterhorn, just over the course of 45 years. This is South Cascade Glacier in Washington State. It's hardly, one can hardly call it a glacier anymore. I mean, a glacier is a river of ice. It's almost to the point where it doesn't exist. And I think if you want to see the nation's glaciers, you need to see them over the next 5 to 10 years. Go to Colorado Glacier National Monument, because there won't be any glaciers there in about 10 years. And the interesting thing is, this is a study that just came out in Science magazine looking at tree rings and other measures of temperature a long time ago, is that if it weren't for human emissions, we'd actually probably be going back into another ice age. We over the last 2,000 years, the Arctic was actually on a steady decline in temperature. I'll come to this in a second, but the ice ages historically have been driven by changes in the Earth's orbit. And we're now orbitally entering a period that would normally see planetary cooling, but because of the Industrial Revolution and the huge amounts of greenhouse gases, the temperature in the Arctic has started to soar. And the result of the Arctic starting to soar is that you've been losing massive amounts of ice. The purple area is the ice the average ice from over 1979 to about 1990. In 2005, we lost a huge amount of ice, and then we lost, this is 2005, this is 2007. In 2007, we lost the equivalent of a Texas and an Alaska in terms of the amount of ice in the surface area of the Arctic that was lost. And let me make 2 points about that. One is that this creates a feedback, because when the sun in the summertime shines straight down on the Arctic, or the ice reflects the sun. But when you start to melt the water and it replaces the reflective ice with the blue ocean, the ocean actually absorbs the sunlight. So the ocean warms up. That causes more melting. Less ice means less reflection, so you get an amplifying feedback. And that's what we're seeing now. This figure is a figure of ice volume. It isn't just that we've been losing area, but the ice itself has becoming thinner. So when you lose surface area and the ice also becomes thinner, then you lose volume. And in fact, we've lost the ice volume was flat from over most of the 80s and 90s, and then it started to precipitously decline. The ice volume has dropped almost in half in the past decade. And when will the Arctic go ice-free? It's a subject of some controversy, but the interesting point is, up until 2 or 3 years ago, every scientific model had said the Arctic would not go ice-free in the summertime until around 2080 or 2100. And I think most people in this room are going to live to see the Arctic go ice-free. So really a pretty dramatic change in the northern hemisphere, which is going to have other serious consequences. If I just go back here for a second, when the Arctic goes ice-free in the summertime, the entire Arctic area is obviously going to be a lot warmer than it used to be in the summertime, because above ice, it can get very, very cold. But above the open ocean, it can only really stay about freezing temperature. So once you warm up the Arctic, then all the area around the Arctic is going to get a lot warmer too. And one of the things that happens to be right near the Arctic, of course, is Greenland. And Greenland is covered mostly with about a mile of ice. And up until, again, a few years ago, everybody thought that it would take 1,000 years to melt Greenland, because they did a simple physics calculation that you put heat in and you melt ice. And it's a pretty straightforward and linear calculation. But it turns out that glaciers don't get, there are other ways that glaciers can disintegrate. In the summertime, this is actually a picture of Greenland. You get these rivers of melted water which flow down to the bottom of the glacier and lubricate the glacier, and the glacier starts sliding on the river of water. So most of the glaciers in Greenland have doubled or tripled in speed, and this is this study that came out in Nature in October about dynamic thinning of Greenland and Antarctica is more pervasive, sensitive, pervasive, enduring, and important than previously realized. And if Greenland were to melt, sea levels would rise about 20 feet. And if Antarctica melts, that's another 200 feet. The good news is it's probably going to take a long time for that to happen. The bad news is once it starts happening, it can be very, very hard to stop. The other thing one has to worry about, and I'll just go back up to this picture, is that in this area around the Arctic is the permafrost. Previously, it was permanently frozen land. It's throughout Siberia, throughout Alaska, and it's like your freezer. It's a frozen locker of carbon, and when it starts to thaw, it releases a huge amount of greenhouse gases. And the great danger is that it's going to create this positive feedback where the loss of sea ice speeds up Arctic warming, the Arctic warming melts the tundra, freeing up carbon dioxide and methane actually traps a lot more heat than carbon dioxide, and that leads to accelerated greenhouse gas warming. Now, some people ask, how do you know that the current climate is the right one? Maybe it'd be great if it was warmer. The problem is that human civilization developed. This is a picture of the last 20,000 years with temperature change here on a y-axis. Since the end of the last ice age, when the northern hemisphere, North America was half covered in ice, the climate of the planet has been pretty stable. And we're right now about as warm as we've ever been, and we're headed up here. So we are headed to warming that is beyond the bounds that human civilization has experienced, and all the people who have, literally billions of people have settled in places that have a livable climate that in a globally warmed world won't be particularly hospitable. This is a little complicated figure, but I want to run through it just to show the difference between the natural cycles historically and what we're doing now. This is a figure. There's a black line, a red line, and a blue line. The black line is carbon. This, goes back 360,000 years, and the black, red, and the black line is carbon dioxide. The red line is temperature, and the blue line is sea level. And one of the things that you see here is that they march together. They don't stray very far. That's sort of one thing that you see. The other thing that you see is when it starts to warm, it can really, really warm very quickly. It cools very slowly, warms quickly, cools slowly, warms quickly, cools slowly. And which is to say, ice ages, which are these low points here, the ice ages last very, very long times. Warm periods don't last very long. Historically, that is to say, over the past, and this goes back 800,000 years, warm periods just last several thousand years. But the reason that the ice ages end is because the Earth's orbit changes to the point where you get a lot more sun in the northern hemisphere in the summer. And that causes the melting of the ice, and as the ice retreats, it warms the land and ocean, and that causes the positive feedback. And that positive feedback releases carbon, which then accelerates the whole thing. So once you start a little bit of warming, it accelerates and snowballs with amplifying feedbacks. Now, what's particularly scary about this, as you can see how closely temperature and sea level rise have marched with CO2, is that CO2 has been bouncing around for a million years between about down here 180 parts per million and up here about 280 or 380 parts per million. 280 and 300 parts per million, which is where we're at, where we were at pre-industrial levels. Before the Industrial Revolution, we were sitting up here, and we were at about 280 parts per million. We're actually now, in CO2 emissions, we are about up here. And we're rising about 2 parts per million a year, which is to say by the middle of the century, we'll be up here, and by the end of the century, we'll be on the second floor. And again, what's scary about it is that sea level rise and temperature eventually catch up. They just always do. In the past, it's been a natural cycle, but we've overtaken the natural cycle. We've with the huge amounts of greenhouse gases that we are slamming into the planet. So we will catch up in temperature, and in fact, a study came out in Science magazine that says that if we just go up another 100 parts per million, which we'll do by mid-century, we'll be as much CO2 as we had 15 million years ago, when the planet was 5 to 10 degrees Fahrenheit warmer and sea levels were 100 feet higher. So needless to say, we don't want to do that for any sustained period of time. There's huge lags between CO2 in the atmosphere and then the warming. That lags a few decades, and then between that warming and the melting of the ice, which can lag even longer. So the point is, we as a planet cannot sustain that for an extended period of time. Let me show you what it would mean for the country and for Texas, Houston in particular. This is the projected end-of-century number of days of the year that a part of the country would be above 90 degrees Fahrenheit. So this is a map of the planet of the United States around the year 2090. This is the number of days per year above 90 degrees Fahrenheit. So you see this yellow, that means you're above 90 degrees Fahrenheit 120 days of the year. So Kansas would be above 90 degrees Fahrenheit 120 days of the year. Not really that hospitable to growing corn more than half the year. I mean, just a radically different climate for the country. And all the, oops-a-daisy, sorry, all the people of the country, as you know, in the last few decades, they've been moving from up here to down here. They'll probably go back. It will be, you know, this is not a hospitable climate, and particularly when you add in what's going to happen to soil moisture and rainfall. Houston, someone did a study, Houston will actually be above 98 degrees Fahrenheit 60 days. So much of the summer, it's going to be pretty hot. Let me skip this slide, and let me skip this slide. Let me talk a little bit about what sea level rise would mean for the Houston area, because someone did a study in July. Some scientists did a study that was published in July. In fact, the Hart Research Institute was involved in this. This is Galveston Bay with 1.5 meters sea level rise, about 5 feet of sea level rise. Everything that is in blue is, you know, this is how the land was. Everything that's in blue is now underwater between low and high tide. And, you know, a radical remaking of Galveston Bay. And in fact, I have another slide here, which was in the figure. This is a little less clear. I'm sorry you can't read the legend. This is the same map and the blued in areas, but all of the colored dots are either hazardous waste sites, Superfund sites, industrial and hazardous waste sites, and municipal solid waste sites. And the green dots are the wastewater treatment plants. Needless to say, the country builds wastewater treatment plants near the water. So we've built billions and billions of dollars of infrastructure right near the coastlines, and it's going to, you know, be a devil of a time figuring out what we're going to save and what we're not going to save. And then on top of that, you have to put in the fact that we're in, you know, Hurricane Alley here. And this is, I'm going to talk about 2 hurricanes. This is Gustav. This is the storm track of Gustav. And the thing about hurricanes, and I spent a lot of time talking to top hurricane scientists, and this is degrees centigrade on the right-hand side. The color code is degrees centigrade here, translated over here. Blue obviously is cold. Dark red is very hot. The thing about hurricanes is that they don't form in water below 80 degrees Fahrenheit. Hurricanes feed off of warm water. That gives the energy that allows them to spin up and stay, form an eye wall. But hurricanes are self-limiting in the following sense. As they become hit Category 3, they start welling up deep water. And if the deep water is cooler, which it normally is, then the hurricanes weaken. And in particular, around the Gulf of Mexico, it tends to be cooler near the coastline, which is why the vast majority of hurricanes that make landfall in the Gulf of Mexico weaken in the last day or so. And so Gustav weakened, I think, from about a 4 to a 2. The thing that makes hurricanes strong is when they pass over deep, warm bodies of water. The Gulf of Mexico splits here, and this is the loop current. The Gulf of Mexico loops around here. And sometimes pieces of the loop current spin off, and they form these eddies, warm eddies. And whenever you get the unfortunate circumstances of a major hurricane passing over one of these warm eddies, it spins up to a Category 4 or a Category 5. And from the point of view of damage, you get damage in a hurricane a couple of different ways. The two main ways are how strong is it at landfall, because that's the intensity of the wind, and how strong was it, 100 miles off of landfall when it creates a storm surge, because it's spinning up and it's creating a huge pressure of air and wind against the water, which it shoves up against the shore. So what we've had in the case of, this is the case of Gustav, and this is the famous storm track of Hurricane Katrina. Katrina also happened to ride, you look at the storm track as it came off here, it hit the loop current into an eddy current that it spun up, and it went up to a Category 5 here, and it spun here, and because it's spinning this way, it's slamming a storm surge, typically on the eastern side, and that's, this is where past Christian is, this is where my brother lived here. The interesting thing, of course, about Katrina is that when it made landfall, it was not a particularly strong hurricane. When it made landfall here at the tip, it was like a weak Category 3, and when it actually hit New Orleans, it was only a Category 2. It was the storm surge and the inadequately designed levees that obviously turned the New Orleans side of the storm into a catastrophe. It was the storm surge, the Category 5 storm surge that devastated everything east of New Orleans. But the key point is, again, body of cool water. The overall, the Gulf of Mexico was about 2 to 4 degrees Fahrenheit warmer than normal in the summer of 2005. 2005 was one of the warmest years on record. And so in the future, we're warming up the Gulf of Mexico. Gulf of Mexico is just going to get warmer and warmer. It's like a bathtub. It's just going to get warmer and warmer. This is actually a study that was done by Oak Ridge just for the year 2050. If you warm maybe 2.6 degrees centigrade, which is a little over 4 Fahrenheit, then the Gulf of Mexico is going to warm 1 to 2 degrees centigrade, and parts of it are going to warm 2 to 4 degrees centigrade. And that, in other words, in the year 2050, the average temperature of the Gulf is going to be what it was in 2005 when Katrina and Rita came in. And in really hot years, it's going to be much hotter than that. So in the coming decades, all of this is going to get redder and redder and redder. So we're not going to, we as I say, the vast majority of Gulf hurricanes that make landfall weaken and turn into Category 2s or so when they make landfall. The great exception, of course, was Camille, and that actually we don't have this data for Camille, but the basic view is that when Camille struck in the late 60s and it was a landfalling Category 5 hurricane, it must have been obviously warm all the way up, and it just happened to ride a warm current straight up. So today we have happenstance. If the hurricane crosses over the loop current, it spins up to a 3 or 4. If it then hits a warm eddy, it spins up to a 4 or 5. We've seen explosive growth of hurricanes in the Gulf, I'm sure you have noticed. So it is just an inescapable fact that in the future, sea levels are going to rise, which is going to leave Houston more exposed, and you're going to see sooner or later you're going to get the Hurricane Ike, except it's not going to make landfall as a Category 2; it'll make landfall as a Category 4. So it's just I'm not selling anything other than what I think is going to happen. I think people are going to I think ultimately it's going to change where people live and choices that they make, and coastal property values. I think it's going to take. I don't think personally that all of this awareness, what I'm telling you, is not something obviously that the general public or understands yet, but it will become painfully obvious over the next 10 to 15 years, and I think by the 2020s, it will be rather painfully obvious what's going to happen. The other thing that is going to happen is we spend a lot of time on sea level rise and hurricanes because people live along the coast, and hurricanes got a lot of attention. Let me make one other point about hurricanes. We're not going to see more hurricanes. That's the best science actually says we may see some fewer hurricanes, but more intense ones. There have been two major studies in the past 3 years that have basically come to that same conclusion. What affects the number of hurricanes in any given year has a lot to do with wind shear and dust coming off of North Africa. So it's very, very hard to predict a year in advance how many hurricanes are going to be. But about half a dozen hurricanes have done half of all the damage done to the United States. So it isn't the quantity of hurricanes that matters. It's your Ikes and your Gustavs and your Ritas and your Katrinas, and it's just really, do you happen to have the happenstance of a hurricane running over a body of hot water and spinning up and then slamming into the coast? The other thing that happens is as you heat up the planet, you create more deserts. Because as you heat up the planet, you're evaporating moisture from the soil. So the soil dries out. The other thing that happens is you expand the subtropics. The climate of the planet in large part, is driven by hot, moist air rising in the tropics. And then it goes up high, it loses its moisture, and it comes down dry. And those are the subtropics, the Tropic of Cancer, Tropic of Capricorn. The deserts, the Sahara Desert, these are all in the subtropics. We are expanding the subtropics. We are desertifying the planet. The easiest place to see that is in the most sensitive climate in the world, which is Australia. Australia is the most arid, habited continent. And if you've been following what's been going on in Southeast Australia, they've had a drought for 13 straight years. It is the worst drought in 1,000 years, and it's getting hotter and drier there, and it's just devastating to farming, and it's created massive dust bowls. And as you can see here from what is predicted, the expansion of the subtropics, it is predicted that the United States from about here up over to Southern California will have levels of soil moisture comparable to the dust bowls of the 1930s. And it's just a pretty standard prediction of climate science. I used to use the term desertification, but then people wrote into my blog that deserts can be kind of nice places with, there's a lot of, some deserts get a fair amount of water and they have plant life and people live there. This is going to be more like the Dust Bowls in the 1930s, and as I say, it's going to totally change lifestyles in the entire Southwest. This notion of having lawns and bringing in millions and millions of people. The notion of having this is the Central Valley of California, which is going to get very dry in the south. Having agriculture built around fruit, where you need massive amounts of water and you're exporting water, all these things are going to change in the future in ways that I don't think people have come to realize. Let me just talk about what I think, we're going to respond. I think fundamentally the climate is changing because we're pouring all these all this carbon dioxide into the atmosphere, which comes from burning fossil fuels. And we're going to replace that. We're going to replace that with clean energy. The nation and the world are slowly coming together to take action. Many countries, I was in Copenhagen, China, India, Brazil, Indonesia, Europe, have been making commitments. I need to update this slide, I realize. I think, I don't know whether the U.S. Congress is going to take action or not. If the U.S. Congress doesn't take action, it's going to slow global action maybe a full decade. But I do know two things. We're not making more fossil fuels, so we're going to get off of fossil fuels one way or another. And the future, I think the biggest growth industry in the lifetimes of most of the students here is going to be clean energy across the board. I mean, I think, or I should say clean technology. There will be jobs in fresh water, in things that purify water, the things that recycle water. There are going to be jobs in clean energy, energy efficiency, smart grid. I mean, all these things are going to be the biggest job-creating industries of the world. The other thing that is going to affect Houston is the price of oil, and the fact that it's pretty clear that we are starting to peak in conventional oil. And the reason oil prices hit $150 a barrel 2 years ago, the only reason they didn't stay their way is because we destroyed oil demand through a global depression. But we're already slowly starting to come out of that, and oil prices, went up to $80 a barrel, and we're still in the middle of a recession. So you can imagine when the global economy really gets going, oil price is going to go over $100 a barrel, and then it's going to go to $150, and then, probably to $200, and gasoline prices are going to go to $4 a gallon, $5 a gallon, $6 a gallon. I don't see any escape from it. It's certainly the International Energy Agency says this. Merrill Lynch says it. I just saw a major study by Deutsche Bank. Since we're not making any oil and we're draining out the fields, we actually need to find a Saudi Arabia of oil every 2 to 4 years just to stop oil production from declining. So this high price of oil is going to also remake the U.S. economy in a sense, that how people travel. Air travel will become, I think, much less common. The way people drive long distances to commute and exurbs and all that, I think will change. I think we will move over to electric drive vehicles because electricity can be made from a variety of sources, and it's much cheaper to drive your car on electricity. The cost of driving an electric car or a plug-in hybrid car on electricity is like under $1 a gallon. So as gasoline goes to $4, $5, and $6 a gallon, I think you're starting to see the major automakers over the next 1 to 3 years are going to introduce a whole bunch of models of pure electric cars, but also these plug-in hybrids that can go 20 to 40 miles on electricity and then revert to being a regular gasoline-driven hybrid. So that solved the biggest problem of electric cars was that they needed massive amounts of batteries, which cost a lot of money, used a lot of weight, and once you ran out of the charge, it took you, hours to recharge, which was very impractical for long trips. So what people realized is that most people don't travel very much every day. People commute 10 miles a day. So if you gave them a modest-sized battery in the car that would give them 20 to 40 mile range, then they could drive to work, maybe charge at work, drive home, charge at home, and you keep the gasoline engine for long trips, but most of the time you'll be driving on electricity. And I think that is the future. I don't have much doubt that you're going to see an explosion of, in this decade, we're going to see a transition towards electric drive vehicles as the price of oil goes up and as the price of batteries come down. If you want to clean up the air, of course, you need electricity that's made from renewable sources, but the good news is that is that we have a lot of clean and renewable sources. I do want to put in a plug for energy efficiency before I get to the renewable energy. This is a chart of electricity use per capita for the nation and for California and for the rest of the nation. And this is the rest of this blue line you could take for Texas is very similar. Texas is basically Texans use twice as much electricity per capita as your average Californian. And California's put a lot of effort into energy efficiency. They have aggressive building codes, and obviously one doesn't have to drive very far in Houston to realize that there aren't a lot of building codes around Houston area. But they also put in a clever rule. Right now, utilities make all their money selling more power. So they don't have any incentive to help you become more efficient. In fact, they have an incentive to help you waste energy, because the more electricity you use, the more money they make. So what California did is they changed the utility regulations to allow utilities to make money, as much money selling efficiency as they did selling electricity, and lo and behold, they started selling lots of efficiency. So I expect that we're going to see that sweep the nation as we get more concerned about global warming. We'll see a lot more energy efficiency, a lot more smart grid technology. Google is already starting to sell home electricity monitors that would allow you to track your electricity use at home and see what your appliances are using. This is a figure I like to put up. The red, this dot is world energy use. This is coal. This is the amount of coal there is. This is uranium, oil, gas, wave energy, wind energy, ocean thermal, bio, hydro, and that's the solar resource. This is all the solar energy that hits the Earth every day. Every year is equal to, vastly more than the amount of energy we use. So it is very safe to say that as we use up all the non-renewable resources, we're going to shift over to a economy that's run on the sunlight, because it's free and it's limitless, and it never runs out. I didn't bring my slide of wind. Texas is the leader in wind power. Texas has more wind power than any other state in the country. Very aggressive policies in Texas for renewable energy and for transmission. The other energy that I think Texas will use with wind power is not, I think, solar photovoltaics. Solar photovoltaics are those panels that you see that convert sunlight directly to electricity. But there's another way to capture sunlight, which is much simpler, which is just take mirrors and reflect the mirrors onto tubes of fluid, heat the fluid up to boiling, and use the boiling fluid to run a steam turbine. Very simple technology, nothing complicated like photovoltaics, which involves semiconductors. And don't get me wrong, I'm a big fan of photovoltaics, I think, and a lot of innovative strategies are coming into photovoltaics to drop their cost. But the nice thing about generating solar thermal heat is that it's much easier to store thermal energy than it is to store electricity. It's quite expensive to store electricity. Batteries cost a lot of money. Whereas storing heat, you do in your thermos, it's very efficient, very cheap. So that one of the biggest problems with solar energy is that it doesn't work when it's cloudy. But you can store the heat here for many, many hours, even into the nighttime. So this concentrated solar thermal power can actually deliver power well into the evening and frankly into the early morning if you want. This is the U.S. solar resource, and you could power the entire country with that much land just on solar energy. Now, the good news is you don't have to power the entire country by solar energy. So you don't need a lot of land. And I think that, as you can see over here in East Texas, there's a lot of sun, and I think you're going to see a lot of solar thermal electricity built in East Texas. It's a very good match with wind, because wind power tends to blow at night, and solar thermal can cover the rest of the day. So you can pretty much run an electric grid on solar, thermal, and wind, with some other things. I mean, sometimes people use natural gas. People talk about hybrid plants where you have solar, thermal, and get natural gas, and they share the turbine. And you use the natural gas when you're not using the sun. So I'm very bullish on natural gas, and natural gas is much lower polluting than coal, and we clearly have a lot more natural gas than people thought. So let me just wrap up here a bit on the early side to answer questions. I think that the science is real. You can read articles by people who are trying to confuse the matter. It's kind of unfortunate that there's an active disinformation campaign to mislead the public, because the consequences of doing nothing are very dire, as you've seen. And I think many of the consequences of global warming are occurring much faster than people had thought, particularly ice. Ice is melting much faster than people thought. And if we don't do anything, we're not going we're going to leave a ruined planet to our children. I think college students out here are going to experience it. Sometimes I just apologize on behalf of my generation. I will say, if we let this happen, then no one is going to be writing books in 30 years about us called the greatest generation. It does require spending some money, but it's just money. Many of the world's problems can't be solved by spending money. This is a problem that isn't entirely solvable by money, but it is largely solvable, and not by a lot of money. We're just talking about a few percent of global wealth redirected from dirty energy to clean energy would do the trick. And I try to keep people informed on my website. I blog professionally. I'm a professional blogger now. That's how I communicate. And so you can go to climateprogress.org if you want to stay up to date on these issues. And I think I'll just end it there and take questions. Thank you.
Like to ask any questions?
I'm curious about the sudden increase in CO2 emissions in the mid-90s. Did that correspond with economic development takeoff in the developing world? And if so, what implication does that have for needing to transfer renewable energy technology to the developing world?
No, it's a good question. What happened is actually quite interesting. It's mostly China. Most of the explosion in emissions growth in the last 10 years is China. From about 1980 to about the mid to late 90s, China actually had a very aggressive program on energy efficiency, and it was actually doing a pretty good job of growing without an exorbitant amount of energy. But around the late 1990s, it just kind of cut loose, and it started growing in a pretty wasteful way, and building coal plants. It was building a staggering amount of coal. China burns now twice as much coal as the United States. In fact, on its current pace, by 2020, it'll be burning 3 times as much coal as the United States. Now, the good news is China's woken up to that, which I'll get to in a second. But so fundamentally, what happened was most of the, I'd say maybe 50 to 60% of the growth in emissions in the last decade has been China. Now, that said, some of it's us, and one thing that's important to realize is that coincides with the time when the U.S. trade deficit with China has exploded. And in fact, people have done analyses. If if the United States had manufactured all the stuff that we bought from China, then our emissions growth rate would have been 3 times faster than it was, and China's would have been, considerably lower. So what has happened is, and this U.S. isn't alone. I mean, Europe's trade deficit with China has exploded. So what happened in the past 10 to 15 years is this exporting of emissions by the industrialized world to China, which unfortunately China is both less efficient than the industrialized world and more coal intensive. So you had this rapid, much faster growth rate in emissions than anyone projected, much faster than the models had projected, which of course is the other reason that scientists are alarmed. Emissions have been trending at the highest end of those estimated by scientists. Now, the partially good news is that China has woken up to the fact that its emissions are unsustainable. It hasn't, it publicly committed to cut the growth rate of emissions in half. It has not, gone as far as it needs to go, but it has also woken up to the fact that the biggest industry of this century is going to be clean energy, and it has decided to be the leader in that industry, and it is putting a huge amount of money and has become the leader in solar photovoltaics. It's become the leader in wind power. It wants to take the leadership in batteries away from Japan, and it's trying to take leadership in electric drive vehicles. It's got more solar hot water heaters than any other country in the world. It has a massive solar hot water program. I mean, I think Shanghai has like 1 million solar hot water heaters on their roofs. I mean, when China decides to do something, it doesn't have to wait for 60 votes in a U.S. Senate. So it's kind of a good news, bad news thing. Right now, China is in the process of becoming both the greenest nation and the dirtiest nation. The worrisome thing for the U.S., from my perspective, is that the U.S. is really good at innovation, but we're not good at follow-through to manufacturing. We aren't committed to the same policies that other countries do to sustain their manufacturing base. So, as I'm sure you know, it is Bell Laboratories in this country that invented the modern solar cell in the late 1950s. But we don't make, maybe, in 1980, we were the world leader, but now we have like 10% of the solar photovoltaic manufacturing market. And the same with wind power. We had more than half the world market in wind power in the early 1980s, but now it's just GE wind. We have about 15% of the world market. So we're in a couple of races. We're in a race to see whether we can deploy clean energy fast enough to avert catastrophic global warming, and we're in a race to see whether the U.S. is going to be creating jobs and economic growth by leading in those industries, or whether other countries we're going to be importing those technologies from other countries.
What is the physical evidence that sea levels have been 75 feet higher than they are now, or more, in the times in the past?
Yeah, there are different places that you look around the planet. You see very clearly sea life fossils in places that are considerably above sea level today, and if you really study the fossil record, then you know that even the Arctic was much warmer, to the point where it had almost the equivalent of tropical vegetation today. But fundamentally, that's the paleoclimate record. That is, people look at the shorelines and inside the shorelines, and they look for the fossils. I think there are other ways of determining sea levels that have to do with sediments in places around the Mediterranean and other places. So you can see the types of sediments that are laid down, and you can tell that this area used to be underwater. So the scientific evidence, and the other calculation you can do is how you know the amount of ice that's on the planet. So you can drill down to the bottom of Greenland, and you see how far the ice goes down. So you can see the ice wasn't there before a certain period of time. And you can tell if Greenland didn't have any ice on it, then sea levels would be 20 feet higher. So you can do both ends of the calculation. You can see the fossils are where they are 100 feet above sea level, but you can also see that the quantity of ice in the great ice sheets is quite sufficient. And we know that about before about 20 million years ago, the planet didn't have much ice on it at all, and Antarctica didn't have a permanent ice sheet. Yeah.
As for the fossils being in elevated positions, there are fossils on top of mountains, and geologists have known for quite some time that this is because of geological uplift. I don't think really has anything to do with sea level rises.
Well, geological uplift, yeah, I mean, there's no question that you have two different effects. But geologists are very good at figuring out the rate of geological uplift, which is relatively slow. And of course, there are many places where you see fossils above sea level that don't have anything to do with geological uplift. As you know, many parts of the planet, some parts are going up and other parts are going down. But yeah, our knowledge of what sea levels are not really in significant dispute. I think it's safe to say we have a lot of coral records. I mean, again, I'm not going to go through all the scientific evidence here, but of the things that are in dispute in the scientific record, the fact that sea levels were 100 feet higher 15 million years ago is not subject to a great deal of dispute.
My son was born at University of Texas Medical Branch in Galveston a couple years ago. And what really struck me is my wife was upstairs and I went down to get some lunch. I guess it says what kind of person I am, but I looked out the front windows there to the garden and I realized, my God, this multi-billion-dollar complex is built at about 6 feet above sea level. And I guess they're building it back after it was destroyed by Ike, or partially destroyed by Ike because of the flooding. Is there anything being done in Washington, perhaps say by FEMA, to take sea level rise into account, maybe changing the way that FEMA requires people to build structures back when they receive federal funding for disaster relief and such?
All I can say is that, right now, state, federal, and local governments are mostly in denial. I heard at dinner about the rebuilding of the medical center. People rebuilding New Orleans, and yet not putting in levees sufficient to withstand a Category 5 hurricane. There's not. Most people in this room are going to live to see the abandonment of New Orleans. It's just not sustainable. Galveston, when it becomes clear what kind of sea level rise we're facing, it's going to, development patterns will change. But, the country obviously isn't there yet. Right now, most of the major insurers have backed away from offering insurance for new coastal property. because of hurricanes. And the biggest insurer of coastal property in Florida is the state of Florida. And if there's a major hurricane again, if a major hurricane were to come anywhere near one of the major cities, the state of Florida would go bankrupt, and they would be expecting you and the rest of the country to bail them out, which we'll probably do, but I don't think we'll keep doing it. So it's just going to, I say it, it's just going to take, it's going to have to take a few more consequentially bad things to happen before people really wake up to this reality. There is obviously immense skepticism out there that this is the future that's coming. So if people don't want to believe scientists, they don't want to believe their doctors when they diagnose them with pre-diabetes and need to tell them need to change their diet, then the only other outcome is they get diabetes and start losing toes. I hate to be that blunt about it, but the fact is that most of the country, most of the major politicians are still in denial about this. You even get the governor of Louisiana, an otherwise serious guy expressing skepticism and doubt and not wanting to plan for the inevitable. Over there.
Yes. Do you see the use of geothermal energy as a substantial, renewable resource in the future? I know it's not available everywhere, but where it is available, it seems to be consistent.
Yeah, I think that there's a lot of money going into geothermal, and there's multiple kinds of geothermal energy. Geothermal energy is tapping the energy of the Earth's heat. Right now, it tends to be done near the so-called Ring of Fire, or places where usually geologically active areas where heat is coming up. And there's a lot of research into using the oil drilling technology to actually drill down deep and inject water down deep. I'm talking a few kilometers deep, and having the water come back up hot. That, as I say, a lot of money is going into that. And then there's geothermal heating and cooling, which is a local technology that you can employ in your own home, where you drill maybe 100 feet down and run a pipe down, or run a fluid down, and use that fluid to preheat the water for your home during the winter and use it as a heat sink for air conditioning, and it is the most efficient form of heating and cooling. And former President George W. Bush has geothermal heating and cooling on his ranch in the state, and I think that will there's a tax credit for that, or there is a tax credit in the stimulus, I think, and I think it's becoming much more popular. So yes, I think we're not even serious about transitioning away from fossil fuels yet. At some point, we will get very serious, and then we will get desperate, and every clean energy technology known to humankind will be aggressively pursued. And I think geothermal will be a big, a medium-sized piece of the puzzle, and possibly a big piece.
But the problem is, it may well be too late when we wake up. I have a master's degree. My wife has a PhD. All of our friends they have PhDs, MDs, masters. They're educated people. I invited a half dozen of them to come tonight, and they aren't here. None of them are here. Here tonight, relatively speaking, this is a handful of people. Everybody in Houston should be here. I've seen, it's not the Gore film, but the film, An Inconvenient Truth. Your presentation, I believe, is much better. It's more to the point. It's not as flashy. It's pithy. But nobody's here. I'm just depressed. I almost can't stand it. I feel hopeless, despondent. Where are the people? You spoke of we. There doesn't seem to be much of a we. There's not much of us here now. the great we seems to be the ones who stand against this. It's not that they're just skeptical, that there are skeptics out there. Yes, they're in denial, but denial seems to be an industry, that this skepticism, it seems to be designed. It seems almost conspiratorial. It seems that there's a movement to just shut this down, to have people like you not be heard. I know when I leave here today and I see my friends or I talk to them, I go home, I send them emails, and I tell them they should have been here. They're going to deride what I have to say. They're going to come up with their arguments. What do we do?
Yeah,
I realize you're
yeah.
doing, you're doing what you can, but the rest of us, what do we do? What can we do?
Well, it's a fair question. I mean, it's an important question. I obviously, personally, I actually don't do a lot of public speaking because I reach a great many more people through the blog, and even people who aren't. I don't. It is, there's kind of three kinds of people. I would say there are people who are understand and accept science. Then there are people in this, who simply deny the science and have been misinformed and who get their news from channels that spread lots of misinformation. But there's a vast sea of people who I think are open and persuadable, and I think one has to try to reach them. I don't personally try to spend a lot of time convincing unconvincible people because it's not productive. I don't think one has to convince every last person. But then again, so I'll give a couple of different answers. No one person can change the world, so I don't think it's the responsibility of anybody who hears this message to feel that they have to become Al Gore. I do think that everyone who understands what's going to happen has some obligation to try to inform the people around them, but that's not what they, it's not their job. I give these talks in part to inform people, but people can make their own, everyone's going to have to make their own decisions. They're going to have to become informed on the subject, decide where they want to live, how they want to live. I urge people always to get more political. In the state of Texas, that's what one has somewhat limited choices, although I can definitely say that it would be a very good thing if my old boss Bill White were to become governor of the state. I think that would be very good for the state of Texas. It is right now in the hands of Congress, and Congress is not a great place. The U.S. political system is very broken. This supermajority requirement of 60 votes in the Senate is anti-democratic. But I think I don't have an easy answer. I urge people to figure out how climate change is going to affect their lives and their children's lives and act accordingly. I think people should try to reduce the amount of emissions they use. I don't think there's a moral imperative to go to zero emissions. I think it's just a great idea to become more efficient and use clean energy. And then, if you're very passionate about it, I would develop an outlet. You can start your own blog. It is one way of reaching people. You may not be able to reach unreachable people, but as I say, it is certainly the case that if one has to wait until everybody believes something to act, then there's no hope of acting. But the country takes action before everybody accepts that action is needed. So again, I don't want to offer any simple answer. As I say, I think people can become more political. They can make choices about how they're going to live their own lives. These are the main things I would recommend. I don't. If I thought it was too late, I wouldn't come out and give talks. I don't think it's too late. I think human race doesn't. There's not a lot of examples in human civilization of the human race acting proactively in this manner. So I can understand that one can come away pessimistic. But my basic view is it's always better to have more information than less information. And I think everybody has to make a judgment in their own lives what would be the most productive use of their time, and how their knowledge affects their decisions.
Thank you. I just wanted to respond to the discussion we just had.
Sure.
Since we are talking here at the university and there are a lot of students, and I'm interested in education, what are your thoughts on science and engineering education in this country that will allow and inspire our younger generation to get more involved along the same lines the gentleman just spoke, and meet or solve these problems or challenges head on? What are your thoughts and what are some of your ideas in that regard?
Sure.
Not only climate change, but there are other lot of
Sure.
technical issues as well. Thank you.
Well, I think that, and I've spent a lot of time at universities. I actually spent a few days at a college last year talking to a lot of students and giving some talks. I think I'll give a few answers to that. One is, university's job is to provide an education and some set of skills and knowledge for the world that people are going to live in. I think that university doesn't have to decide whether it believes in science or not. Obviously, it does believe in science. This university, as much as any, is going to be affected by global warming. So I think that the university as a whole has to figure out how global warming is going to impact it. How is it going to survive? I mean, unlike other institutions, universities do plan to be around for 50 or 100 years. So you don't necessarily have exactly the same quarterly profit mentality. So I think, I would urge I always urge universities to set up a planning committee that has three facets, one of which is how you might do relevant education around this. I think students not only need to understand this world, but frankly, there's a whole bunch of skills that are going to be quite valuable in the coming decades, having to do with understanding climate, understanding engineering, because there's going to be massive amounts of jobs, people making levees and redesigning cities. I mean, one thing I didn't get into on sea level rise is sea levels don't just sort of jump up here and stop. They're going to rise, and if they keep rising, they'll eventually rise like an inch a year. We'll get like around this second half of this century, they'll get to an inch a year, and then they'll do that for centuries. So someone's going to have to figure out how you design ports when sea levels are quite dynamic. My personal view is I think that when we get desperate, which I think will be around the 2020s, the entire intellectual capacity of this country will shift towards global warming. It will shift towards mitigating, clean energy and fresh water and adaptation. So the great universities, including this one, will be focused on a lot of things having to do with, how does the state of Texas adapt and how does the state of Texas transition to clean energy? Obviously, you're right next to NASA. You're with NASA. NASA is one of the principal federal agencies in observing the Earth and figuring out what's going to happen. So I do think it's incumbent on the university to have a whole strategy in that regard. I think the university will need a strategy on how does it reduce its own emissions. Many universities, I don't know whether you have a greenhouse gas target, but hundreds of universities around the country have greenhouse gas mitigation plans that help them decide. I was just at Elizabethtown College. They're going to put in a geothermal heating and cooling. Universities have a lot of land, Land is what you need for geothermal heating and cooling. You just drill down. If you can hook up geothermal heating and cooling with renewable energy, you got a very low carbon system that provides very high quality heat and cold. So there's a whole raft of things around how the university becomes greener. And then there's the ultimate planning for the worst case, because the worst case is worse than this. I skipped over the real worst case. I think the scientific community has failed to explain to the public that what I described is actually just business as usual. The worst case would be if a bunch of things happened that were quite out of left field. So, the university has to think very hard, because that hurricane is going to come. Maybe it won't, but if it doesn't come, that'll just be luck, and one doesn't really want to build a whole institution around luck, because obviously, as New Orleans found, the luck can turn pretty quickly. So I do think that studies have started to be done about, the graphs that I showed you were from a study that Hark and others did on the infrastructure implications of sea level rise in the Houston Ship Channel. But I think one has to combine that with the hurricane issue and make some decisions there. So, I wouldn't presume to tell you what to do, but you have a lot to think about, and I think that it's always better to think about these things before the levees break.
Are there any further questions? Yeah, just one more.
Okay, you said the temperature go up constantly, but I've heard if the ice around the Arctic Ocean melts down, the sea temperature goes up, and the warm sea temperature would not be able to run the ocean current, which is the driving force. And because it cannot cool down the warm current coming from the south, thereby stopping the entire world ocean current system, which would eventually lead to ice age. I'm confused which one to believe, and also, are most statistical data reliable? Because some hackers in United Kingdom released an email that says, from environmental scientists also in Copenhagen months ago, saying some notable scientists manipulated the data. Is it true? And also, another one. What do you think about the recent massive snowstorm that struck U.S. Up in the part of north, and some historical snowstorm, including Houston?
All right, there's a lot of questions. I will let me just make a note so I can answer them all. Let me start with the first one, which is the scenario that was laid out where global warming triggers an ice age. That was the basis of a really dopey movie called what is the Day After Tomorrow, or that scenario exists only in a movie. It does not exist in the scientific literature. I was at the Scripps Institution of Oceanography for about 2.5 years, so I could say the following. Let me just show a picture here, so I can perhaps, if I have, do I have a picture of the world here? So a good picture of the world. Here we go. Yeah, this, by the way, is actually the worst case scenario. This would be a 7 to 10 degrees centigrade warming over the entire U.S. But there is the entire ocean circulation system of the world, of the at least the Atlantic, has to do with warm water coming up here, passes by the Mediterranean, which is salty. So it picks up salt water, and it gets colder, and it dives down around Greenland, and it comes down the eastern seaboard kind of deep and cold. And so it creates a conveyor belt that keeps going around and around and around. And there are people who notice that if Greenland were to melt, it would dump a whole lot of fresh water onto the ocean circulation, which is built around this salty water descending, and it would just overturn the entire circulation. And as a result, the conveyor belt would stop, and the Gulf Stream would end, and the Gulf Stream helps keep, or actually, technically it's called the thermohaline circulation and not the Gulf Stream. The thermohaline circulation warms up Europe a few degrees centigrade warmer than it would otherwise be. But the fact of the matter is that if the Gulf Stream, if that circulation were to stop, no one really knows what would happen. I think the scientific literature now thinks that it's unlikely to happen for a century, and the planet will be so damn warm that no one's going to notice that teeny amount of cold. I mean, in this scenario, Europe is 7 degrees centigrade warmer. So, no, I wouldn't get my science from movies, and I'm being serious about that. There's no question that people used to talk about that scenario, and I think even Al Gore sometimes mentions it in his movie. It's not impossible at all that the entire circulation of the ocean will change. I expect the climate of the planet is going to change radically. I mean, if the Arctic goes ice-free, the U.S. climate is driven by the south by the subtropics coming up this way, but our climate is also driven by the jet stream. And the jet stream is going to change radically if the Arctic goes ice-free, because you won't be able to pump as much cold air down as you used to, and no one has any idea except to say that I expect the weather of the United States will get wildly erratic. I mean, you're already starting to notice it. That huge flood in Georgia that occurred a few months ago, the greatest amount of rainfall in around Atlanta in their recorded history. What people didn't tell you was all the previous records for rainfall in Georgia had occurred during a tropical storm or hurricane. This was rainfall that occurred just because the climate was changing. So, the climate is going to change radically, and no one knows exactly what the implications are, except all the people who base their entire lives around the existing climate are going to be, I think, fairly unhappy. The second, let me answer the third, I'll answer the second one. The second one had to do with the emails. I think that, I sort of make one basic statement, which is that if you publish the emails of anybody, they would have a lot of explaining to do. The scientific community, the scientific community has been under assault from, disinformation funded by fossil fuel companies, some of them based in this state. And scientists are just human beings, and some of them did not react very well, and they've written probably intemperate things. But the great thing about science, certainly one of the reasons I went into science, is that it is quite impervious to the flaws of individual human beings. And it is the one great enterprise that humans have created that is designed to be impervious to the fact that humans are incredibly flawed people. But they do science, they publish it. Other scientists try desperately to prove them wrong. There's this myth out there that scientists spend their lives agreeing with each other. That is not how you become a successful scientist. No one wants to waste their career proving someone else was right. That's an utter waste of their lives, and they would never become famous. The fact is that climate science is incredibly robust because many of the most brilliant scientists in the world have spent their careers trying to kick it and beat it, and they haven't been able to. And almost all the data is public, and all of NASA's data is published. And for all the complaints that you read by the anti-science, disinformers, as I call them, they've never been able to take the NASA data and show that NASA did anything wrong. All temperature data has to be statistically altered. There's just no way around it. And much of the data but it's all public. It's all published, and all the statistical tricks that are used in order to make data work. And the fact is that temperature stations move, our technology shifts. So the things that we measure temperature with today are completely different than they were 50 or 60 years ago. And people find out that there was systematic errors, and then they know that because they compare that temperature data to other temperature data. So there's the notion that there's anything wrong with statistically manipulating data, is just fallacious. And I would just say every medical procedure or pill that you've ever taken was done on the basis of clinical trials where some data was thrown out because people had a reason to throw that data out. And there's just not a drug or diagnosis that you have that is not done on the basis of statistically manipulated data. So, if you don't trust scientists, I wouldn't go to doctors, I wouldn't get in airplanes, I wouldn't buy computers. But the beauty of science is that if we couldn't put a man on the moon, we put a man on the moon, it was not by accident. It's because science works through a reproducible and testable process. And the last bit is the fact that it was cold in parts of the world for just about a week or two. December was actually, for all the talk about December being cold, December was actually not anywhere near the coldest December in the U.S. temperature record. And worldwide, December was still like the 5th warmest December on record. And January and by the way, November, in the NASA data set, November was the hottest November on record. January is actually going to be the hottest January on record in the satellite data record. I published this on my blog. Even though parts of North America and parts of Europe were cold, the fact is it was due to this Arctic oscillation, which meant that the Arctic itself was incredibly hot. And I recognize, and actually NASA just released on Thursday its annual summary of the temperature data, and which I just published up here. The 2009 was the 2nd hottest year on record, and 2010 will probably be the hottest year on record. That's a better than 50-50 chance. I'd say it's probably much higher than that. It is unfortunate that 2008 and 2009 were on the coolish side over the 1.5% of the planet that constitutes the United States, continental United States. But the fact is that over vast parts of the ocean, it's been the hottest year. In fact, 2009 was, I could have put that slide up. 2009 was the hottest year on record in the southern hemisphere, which is mostly ocean. So yeah, I think that it is very easy to confuse weather with climate, and the disinformation campaign tries to do that. And I'll just make a last point about snow. Extreme snow is not evidence of cooling. If it snowed regularly where it didn't used to snow, that would be evidence. But the science is very clear that if you put more water vapor, if you heat up the planet, you put more water vapor in the atmosphere, and you expect more precipitation. And not only do you expect more precipitation, but you actually expect the precipitation to come down in deluges. And that's a pretty robust prediction, that you will get more intense rain events, more rain coming down in a 24-hour period or a 48-hour period. And in fact, when I came back from Copenhagen, we had this amazing snowstorm in Washington, D.C. and up the East Coast. It set records for one-day snowfall. But snowing in January is not surprising, but massive dump of precipitation in one day is something people are going to have to get used to. You're going to see more snow above the snow line, but the snow line is going to move up and up. And of course, if this were to come true, then most of the country would never see snow except under very rare circumstances. But the evidence of climate of warming is so strong that the phrase that the scientists use is unequivocal. The warming is unequivocal. As I say, most of the warming has gone into the oceans. Some of the warming has gone into melting ice. The land gets affected by different things like El Nino and La Nina, but it's very hard to stop the march of warming unless you dramatically reduce emissions.
Okay, with that, I'd like to thank our speaker. And also, I'd like to invite everyone to a reception downstairs. We have, I guess, a few snacks and things set up. So if you'd like to meet Dr. Romm personally, then he'll be down there. Thank you.